Good day, these are vectors. I think we're down to the last 2 or 3, maybe 4 videos, and then we're done. Vector AD. So there are several ways for me to get from A to D, right? AD isn't known, so I can walk from A to B, then from B to D. That is how I can get to D, right? So therefore, vector AD is equal to vector AB plus I'm moving from A to B and then from B to D, right? So now AB is going to be X, BD is going to be 2X plus 6Y. So add them up, and I get 3X plus 6Y. Bam. This is the vector AD. Now B to C. B to C, there are several. I can go from B to D and from D to C. Now, notice something here. From C to D, I'm flowing positive, but now I have to flow against that. So now this becomes a negative of whatever it is. So BC is equal to BD plus DC, right? Once again, BD is going to be 2X plus 6Y, all right? And BD, DB, I'm now flowing against the grain, so it now becomes a minus 2Y instead of a plus 2Y. Minus 2Y. Adding them up, I get 2X plus 4Y. Okay, good. Now it says here, write two geometrical properties of AD and BC. The first one is, I can't see anything right away, but what do I see? That AD is equal to 1.5 times of BC. How do I know this? 4 times 1.5 is going to be 6. So 6 divided by 4 is 1.5, and 3 divided by 2 is 1.5. Therefore, vector AD is equal to 1.5 times BC, sorry for that. Therefore, once they are proportional, all right, they are also flowing in the same direction, and they are proportional. Therefore, I consider these vectors are parallel. AD is parallel with BC. AD is parallel to BC. Next one is, this is a little stretch to see, but I have a vector OX and OY are position vectors relative to the origin. So they are in respect to origin. See, I have a rough drawing over here. All right. So OX is the vector 13 minus 9. So it says to write these as column vectors, which is going to be very easy. The X is on the top, Y is on the bottom. This is a column vector, 13 minus 9. X is 13, Y is minus 9. X is minus 7, Y is 24. Now, remember, I would have showed you that a positive Y means that I'm going up. A negative Y means I'm going down. A positive X means I'm going to the right, and a negative X means I'm going to the left. Okay? That's all you remember for that. So now it says here, express XY as a column vector. Now what I did roughly was to draw a rough diagram so that we can get a feel for this. So OX, so that is equal to 13. See, I go over 13 and then it says minus 9, so I move down 9. So OX is equal to this vector right here. See that? This is just a rough diagram. OY, I am going O to Y. I am going sorry, but it was hard to see that just now. OY is equal to minus 7 and 24. See, X is minus 7, so I'm going to the left, and then I'm going up 24 units, roughly. So OY looks like this, roughly. So now, how do I find XY? From X to Y. X to Y. So I have to go this way and then that way. So it'll be XO plus OY. But XO is equal to minus OX. See OX up here? So everything changes to minus. Minus 13 and plus 9. Plus OY, minus 7 and minus 7 and 24. Adding them up. Minus 13 plus minus 7 is equal to minus 20. 9 plus 24 is equal to 33. What does that mean? I have to move from here over minus 20 units, and then I'm going up 33 units, and that's my vector. All right. The magnitude of OY. Now, OY is already given to us. See, OY is equal to 724. So using Pythagoras, you see that? I got to find the length of this. So I get this leg squared plus that leg squared. Doesn't matter if it's negative or positive, because if you square a negative number, you end up with a positive number anyway. So I get 7 squared plus 24 squared. Taking the square root of that, I get 25 units. So that means that this length here is going to be 25 units long. Now let's move back over here. Express in terms of A, B, and C in simplest form. AC, from A to C. From A to C. All right. Okay. So from A to C. All right. That's from here to here. I can go here from A to D, and then I go from D to C. So AC vector is equal to AD vector plus DC vector. AD is equal to A minus B plus DC vector is equal to 7A minus 2B. Add a number. A plus 7A is equal to 8A minus B minus 2B is equal to minus 3B. Done. Now let's find BC. Now where is BC? I'm flowing from B and I'm going to C. How can I get there? I can go this way, then that way, right? Or I can go, or no. But the thing is, there's nothing here, so I go here, then here, and then here, right? So adding up all those vectors, so DC is equal to BA, or which is the negative flow. I'm flowing against the grain, so now this plus 5A becomes a minus 5A. I'm flowing this way, so this will remain as is. I'm flowing this way, so this remain as is. Minus 5A plus A minus B plus 7A minus 2B minus 5A plus A is equal to minus 4A plus 7A is equal to 3A. Minus B minus 2B is equal to minus 3B. So my BC vector is equal to 3A minus 3B. Now it says here, there's two geometrical properties of AD and BC. AD and BC. What is AD? AD is equal to A minus B, right? But BC is equal to 3A minus 3B. And if you notice something here, this is going to be 3 times as large. So BC is equal to 3 times AD, right? BC is equal to 3 times AD. It's a scale factor. And therefore, AD and BC are parallel. AD and BC. See, A to D and B to C, because they're flowing in the same direction and they are proportionally equal. All right. Last matrix question. On a graph paper, we are going to graph this from, my x-axis is going to be from 0 to 16. Y-axis is from 0 to 16. That is what we did over here. See 16, and it starts down here 0, so it looks up like that. All right. So now the first thing I have to plot is my point L. L is the point 2,8. See, 2,8 is right here. X is 2, Y is 8. Right? LM. And I have to add this to my original. So I end up with LM vector is equal to 2,8, which is L, plus the translation is equal to 8, 16. So I plot 8, 16. So X is 8. X is 8 right here. So you go up, go up, go up, go up, go up, go up, and 16. 8, 16. You see that? All right. Now, next one, Ln. Ln is equal to the original vector L plus N plus the translation. So basically, these are translation vectors. So you add them together. 2 plus 12 is 14. 8 plus minus 5 is 3. So I'm going to get 14 minus 14 and 3. See? 14 and 3. All right? So this is my vector. So this is my point N. Now it says here, Mn. M flowing to N. right? M flowing to N. See, it's flowing this way. So now there are two ways of doing this. I can either literally count this, and I have to go down. I have to go down. I have to go down. How much? 13. So X is, how far is X over from this? X is right here. So 1, 2, 3, 4, 5, 6. See 6 right there. And then I see I have to go over 6, and then I go down 13. If you counted it. So if you counted it, it would be 6 minus 13. Or what you can do is Mn is equal to ML plus Ln. Ln we know is 14.3. ML is equal to minus 8 minus 16, because we are flowing the opposite way. So what I'm going to do is add these together, and I get 6 minus 13, the same way as if you were actually counting it, going over 6 and then down 13. Okay. The magnitude of Ln, once again, Ln. Now, what you can do, using a ruler, I see that this is my line right here. So how far is this up? I have to count these units, and I believe that would be 5 units high. And how far is this over? And this is going to be like 12 units over. All right. If you have graphic, you can verify this. And Ln is equal to, using Pythagoras, the hypotenuse squared, which is Ln, or the magnitude of Ln, is equal to 12 squared plus 5 squared all squared root is equal to 13 units. All right. I left with the middle portion of this. This is only a few points, and this is a lot of explanation. Let's just stick it with God, and hopefully this won't come. Be blessed, be encouraged in Jesus' name, amen.